Hey there, AP Stats kids. Today we're going to be looking at 8.3, estimating a population mean. It's going to be all the same stuff we did before, but instead of proportions, we're going to be looking at means. So some of our equations are going to change slightly. Okay? Hiya, we did it. Alright, so our learning targets today, we're going to look at finding the confidence interval. We're going to state and check. We're going to constrain. It's all the same stuff we did before, guys. Exactly the same. Just different formulas, okay? Come here. Two people want to say hi. Say hi.
Hi. Hi.
All right, now go.
I'm June.
No, get out of here. Go do your stuff.
I'm Audrey.
Yep, that's... Okay, cool. All right. So now this is a problem we did previously with proportions, right? So we did our point estimate plus or minus our z times our standard deviation, right? This can be very similar to what we're going to do today. It's the statistic plus or minus critical value times standard deviation. Face up here. Alright, the same concept. Instead of our proportion, we're finding the mean. We're still using that. Well, we aren't going to use z, but I'll show you why. And our standard deviation now is our standard deviation of our sample divided by how big was our sample size? Square root of n. Alright? So, also same thing, except for it's mean, not proportion. Alright? You know what I mean? So, it's hard to test this one. Proportions, you can know what the population is. It's hard with mean. Okay? Now, one thing that stinks is this. Here was a bunch of things we made with a 99% confidence level, but you can see only 92% hit it. Because Z doesn't work too well, okay? So, you can read, it just doesn't work. So we're going to use something else. We're going to use T, okay? T is based on degrees of freedom. Your degrees of freedom is 1 less than your sample size. Because your sample size makes a bigger impact than it does with proportion. Okay? So this is our money formula right here. We're going to see this again in class. That's how we find our confidence interval. Mean of the sample plus or minus t from the table times your standard deviation of your sample divided by square root of n. Okay? Your degrees of freedom come from n minus 1. Okay? I don't know what my hair is doing. It's dry in here. Alright, next one. Let's look at one. Let's learn how to use the table. Table B! Alright. So in A, we want 95% confidence with a sample size of 12. So my degrees of freedom are going to be 12 minus 1, right? Which is 11. Now 95% confidence, this is again the tail thing. This mill's 95. Then each of these pieces is 0.025, right? That's how we get 0.025. And that's how we get our T is 2.201. Alright? Now for B, 90%, oh, I need to go forward. We're going to round. You always round down. Because our table doesn't go up to 48. So we're going to do our degree of freedom is 40. 48 minus 1 is 47. It's in the 40s. 90% confident means that each tail has to be 0.05. Okay, and we put our 0.9 here. So when we do that, we get our T is 1.648. Alright? Next slide. Oh, you can also do this on the calculator. I highly don't recommend you use a calculator for it. It's just, you can, if you want. It's more exact. I mean, it's right there. You guys can do either one. Now, just like with proportions, there's certain conditions that must be met in order to estimate mu, your parameter. The random has to be there, and that's really important. 10% condition has to be there, and it has to be normal. Now for normal for this one, we don't have to do n times p or n times 1 minus p. We just look at the law of large counts. The law of large counts states that your sample has to be of over 30. The other thing you could do is, if the population is normal, your sample will be normal. And that's all it says here. Same thing, 10% rule random, and the population can be normal, samples is bigger than 30, or it's less than 30 and we don't know distribution, but we look at the sample data and it looks normal. Okay? Let's look at this beast. Let's look at this example and see if the normal large condition is met. So you randomly select 50 students to find their GPA. Right away I'm going to tell you, yeah, it does. 50 is bigger than 30. That's the easy one to do. Next one. You're taking a sample from forced to pull wood apart. Take 20 pieces. 20 is less than 30. When you look at this data, I would say that's skewed left. So no, doesn't pass. Yep. Last one. This one, take a sample of 20. And let's look at it. That looks pretty symmetric. Look at your first and third quartile. So I'd say yeah. Moderately skewed, not severe skew. Alright? Alright. Make sure that you can go ahead and read this. Make sure all the conditions are met. Sample size small means you can still be normal. Careful. State plan do still conclude still is a thing. Let's just try some. Again, this is a lot of review, guys. Go ahead and pause this, read it. I'm going to put my face up here on the books. So, they're taking a random sample of 1,520 people, and they're finding out the average number of books read. In their sample, they found the mean was 12 books, and the standard deviation was 18 books. So now we need to make a 95% confidence interval based on that information. You can, so right away I'm gonna think it's gonna be my mean, which is 12, plus or minus my t times square root of my standard deviation over square root of 1520. That's it. That would be our. That's how fast we can do it. Okay. Let's see what they got. Sorry, guys. Sore throat, cough drop. You guys can deal. All right. So first thing we're going to do is state the problem. We want the true mean number of books read by all Americans last 12 months. 95% confidence. We're going to do a one sample t interval test for mu for our parameter. Was it random? Yes. Is 1520 less than 10% of all adults? Yes. Is the sample size bigger than 30? Yes. So we planned it. Time for do. Do. 12 plus or minus. Use my table to find t. I get 1.962 times my standard deviation. Add it, subtract it, interval. Conclude. You're 95% confident that the interval from 11.09 to 12.91 books captures the true mean number of books read by all American adults in the previous 12 months. Now, is 14 reasonable? Or is it reasonable to conclude that that the means changed in the last 5 years? Yes. 14's not in the confidence interval. So it's not a plausible value for the mean from 2016 So there's evidence that it changed. So because 14 is not in it, it changed. There's good evidence. 95% sure it changed. Let's do another one. Read it, love it, learn it. All right, so let's look at the screens. We took a sample of 20 screens. We need to make a confidence interval. So first, let's state what we're trying to find. We're trying to find the mean tension of all screens produced on that day. 90% confidence. So that's what we're looking for. The true mean of the tension produced on that day. Plan. Let's check it. One sample t-test for you, or from you. Is it random? Yes. 10%? Yes. Normal, large. When we look at the data, it is normal. Like it appears to be normal, our sample. Okay? So let's do. I'm going to find the mean using my calculator, because I'm not a fool. And I'm going to do plus or minus my t from my chart or table times my standard deviation from my calculator, or square root of 20. That's all there is to it, guys. We'll do a bunch of these. They're awesome. I'll also go over margin of error with you guys in class. I gotta go, though. Have a great day.